Welcome to the 9th video in the mathsonlinetuition.com videos. We're starting off with chapter 4, so we are making progress throughout the book. Chapter 4 starts with, after completing this chapter, you should be able to sketch cubic graphs, sketch the graph of the reciprocal functions y equals k of x, find where the curve intersects, and understand how the transformations affect the curve. So let's get straight into it. Now we are introduced to cubic curves. So we have y equals ax cubed plus bx squared plus cx plus d. My advice to you would be to have a revision sheet where you can write out everything that we have done so far, so that you don't get confused and you also don't forget what equation means what. Again, this is cubic, this is quadratic, okay, and this is linear. Alright, remember this, it's very important. Here you'll see in this particular example that they've already provided you with a factorized version of a equation. In this particular chapter, I believe that we'll be going through these examples having already been provided with a factorized version of the cubic expression. The reason is because in this particular chapter all we want to know or focus on is plotting graphs. We will come to a chapter later on where we discuss how to factorize cubed equations. But for now, all the questions will be posed as such. Okay, so let's do the example 1. So we have y equals x minus 2, and then we have x minus 1, and we have x plus 1. So off the bat, the first step 1, okay, is done as follows. Now in this particular example, that they've equated everything to 0. Then this allows them once again to find the roots. And then after they found the roots, they found the root that corresponds to the y-axis, the intersection of the y-axis, and they have all the points of intersection with the axes. Then they've gone on to establish, okay, the way that the graph will look like. And this is the important point. This is the new part of this question that you wouldn't have done before. So let's use the fact that they've already done half the work for us. Y, x, 2 there, 1 there, minus 1, 2 there. Okay, now the way to resolve this, they phrased it as, check what happens to y for large positive and negative values of x. Okay, when x is large and positive, y is large and positive. When x is large and negative, y is large and negative. What does this mean? A very simple way that I like to figure this out, okay, and a very easy to do method is as follows. Okay, take a value, right, after, in between, and after, to figure out where the curve ventures off, alright, past this particular point. So because we know that the graph intersects in this particular fashion, then it's a given that it will do this, okay, because it intersects at this point and these points. That's fine. So where does the curve go after? Does it go here or does it go here? Right, so let's think about this. Let's just take 1.5, okay, a nice number that we can deal with, and we can put it into the equation. 1.5 minus 2, 1.5 minus 1. Then we have 1.5 plus 1. Suffice to say, we'll have here minus 0.5, we'll have here 0.5, and we'll have here 2.5. The main reason for doing this is to figure out what kind of, whether it will be positive or negative, and you can see that this will be negative. So that indicates that the line actually drops, and then it'll come back up here. Similar thing here, let's take 5 as an example, so 5 will be later on down there. Let's take 5, we'll say 5 minus 2 we'll say 5 minus 1, and then 5 plus 2. Okay. Again, this is going to be positive, this is going to be positive, this is going to be positive. So we know that this is going to be a positive answer, which indicates it's going to go that way, right? And another thing that is evident is as the number gets larger, obviously this will get larger as a result. The subject will become larger, the number will become larger as x becomes larger, so it goes off into infinity, and that's what's indicated by this infinity here and here. And likewise, if we were to take a negative number, we'll see that the result that we get is negative as well, so that's why it declines down there. And you can see that that's the graph that we've got here, identical to our graph here. Okay, that's it, that's as simple as it is. Again, just briefly going over this answer. So once again, they've taken the factorized form, they've extracted the points where the y is equal to 0, that's on the x axis. Okay, they have these numbers, so it crosses at these points, and then they've multiplied, they've taken x to be 0, which happens on the y axis. They get y to be minus 2, so the curve has these points of intersection with the axes. And then they've done a similar idea to what we mentioned before. They said, right, what happens if we take a number here, 3, then they put it into the equation above, okay, and if you put it in 3, so you have 1 here, you have minus 2, and you have 4. So this is going to be positive, this is going to be positive, but this is negative. So that means the whole thing is going to be negative. The answer, the numerical value will be negative. So that means it goes down. Okay, and you can see that they've scrolled down. And again, between 1 and 2, they realize the number is positive, so they put it up there. And obviously, just from the crossing of the curve, we know that it's automatically going to take that shape there. And again, the number, if we take it past minus 1, the y will be great, it will be positive, so it will go off into y infinity. So that explains this: when x is going to a negative number, i.e. down this route towards negative, that y will go towards a positive value, okay, which is why you have that positive infinity there. Another example that you can do in your own time, another example here. This particular example here, don't be fooled or tricked into thinking it's anything different. Okay, literally all they've done is they have that squared there, so that means that you're going to have the points sort of, it's an equal root, you can say it's an equal root, right? So it's going to cross at +1, okay. And then again they've sketched it out as follows. X plus 1 has a double root, and the double root, from what you should appreciate is, if you were to zoom in, okay, to a graph, let's say you had a magnifying glass and you zoomed in by, like, I don't know, times 10,000 or something. It's just a number to illustrate like how much of a zoom. You might realize that actually what looks here to be just one intersection, okay, would be like a double intersection, but it's so small, like you'd have to look at it so zoomed in, magnified, that it just appears to us and is drawn as such, just as one touch with the axis. Okay, that's just for you to understand and appreciate why they call it a double root, because technically it is a double root, but you wouldn't be able to see, it's unproductive to draw it as two bumps. So here they've asked you to factorize. Okay, this is a simple factorization, however, where they've literally just taken x outside. You have a quadratic, as was usually the case, and you factorized conventionally, as we've done many times before. Okay, simple again, points there, and then they've tested it out by saying what happens when x is greater than 3, between 0 and 3, between 0 and -1, and after -1. And again, if I'm going too quickly here, the intent of these videos is not to go through everything in detail, it's to give you the basic idea and the fundamental principles, and you should be able to then copy that that principle and apply it to the subsequent questions. So this is where we come to 4.2. You need to be able to sketch and interpret graphs of cubic functions of the form y equals x cubed. So in example 4, right, we can see that equation y equals x3, right? So the first thing they want to do is appreciate where it crosses on the x-axis. Okay, so if y is equal to 0, then x is going to be equal to 0. So it crosses at the origin, and then all they've literally done next is just taken, just from their own discretion, the value between -2 and 2 for x. Okay, that was just something that they decided. It could have been 1 to 5, it could have been 5 to 7, 7 till -3. It's up to them. They just chose these numbers. Okay, and then -2, -1, 1, 2. Remember, this is all they've just done this for short-handedness, but actually the proper way of writing it out would have been like this: 2 and 0, 1 and 0. This is the x coordinate and the y coordinate, but I'm sure you knew that already. Okay, and then literally all they've done is they've cubed it. So -2, okay, cubed, -1, -1 cubed, 0 cubed, 1 cubed, 2 cubed, and then they just plotted it. So for 2, you can see that it's crossing at 8. It's at 8, 1, 0, or -1 will be at -1, and then -8. The indentation sometimes is deceiving, but that's the negative sign there. Okay, it crosses there. So if we draw it out, it will come like this. Sorry about my very, very terrible graph drawing skills. Okay, that's meant to be one line. Sorry about that, I just didn't look very well. It's meant to, essentially, look, you've got a perfect example here. Okay, that's what it's meant to look like. So if we carry on, this just gives you an appreciation of the y equals x3 we've just marked out, and y equals minus or negative x3. Okay, it will almost be a reflection, a symmetrical reflection. Okay, just remember that for future. And excuse me. Now you can see what happens. They're starting to implement the addition or the manipulation of the equations, and they show you what happens in particular scenarios when you have new terms. So here we have +3. Okay, and you can see that when you add something, it actually shifts the graph to the left, and then you'll come to realize when you take away something, it will shift the graph to the right. So a good way to remember this is so adding terms, okay, shifts graph left. Taking away, okay, shifts graph right. So it'll be the exact same style, structure, shape, but the coordinates will just have been shifted. And then again, likewise, you can see here, you've got 3 minus x to the cubed, okay, and you can see that it's been shifted to the right. Excuse me, it's been shifted to the right. Here's some exercises. We're going to go through 4.3, and 4.3 reads as follows. It says you need to be able to sketch the reciprocal function y equals k over x, where k is a constant. Constant meaning here that it stays the same, does not change, as opposed to x being a variable. Terminology is very important in terms of more advanced level mathematics, especially when you're trying to familiarize yourself with it at the beginning. This is a variable x. X is just the sign that we've taken to represent a number. We could have used x, we could have used y, we could have used z, we could have used k, we could have used l, we could have used m, we could have used n. I hope you get the point I'm trying to mention here. These are called variables. They vary. The number could be 1, it could be 2, could be 3, could be 4, depending on what you're being asked to find out, depending on the equation, depending on different knowns that you have, etc. K is a constant in this particular case, so we wouldn't have been able to use k because then it would have led to confusion. K is always going to be a single number. So let's say, for example, in this particular case, it says that k here is greater than 0, and it will always be one number. So for example, it could be k could be 3, okay, k could be 4. It never changes. It's either one or the other in a single example, okay? Just a point that I wanted to mention. So sketch the curve y equals 1 over x and its asymptotes. So y equals 1 over x. When x is equals to 0, y is not defined. Asymptotes never touch the axes. Never ever touch the axes, right? It's like the it's like the exponential, okay? Never touches the axes. All right, because if you have x is equal to 0, you get 1. Okay, simple as. And when e is equal to 0, if memory serves me correctly, that means this is on the y-axis, which means it's going to be on x-axis. I can't remember what x will be, but regardless, the idea here is that the asymptote never touches the axes, and they have these value of x1 to 1. Again, they've just chosen this themselves just to illustrate the example, to progress through the question, and then they've put it into y equals 1 over x, and you can see that this is the result they get. They've then plotted it. It's very simple basically. Here you have a set of numbers, here is the value, here's the equation that they've given you. Plug x into there. 1 divided by minus 1, you get minus 1. Minus a half divided by 1 over minus a half gives you minus 2, etc, etc. Very straightforward. You shouldn't have a problem. The curves with the equations y equals x over k over x fall into two categories, okay? If k is greater than 0, then you have this particular curve category, and if k is less than 0, you have this particular curve category, okay? And then they go on to give you the examples here. So for positive, positive, right? And then you can see that it lands in this particular situation, like so. and then you've got B, negative, negative, and so you can see this particular situation here. Alright, or as they phrased it in the, if it's, so let's write this out. If it's positive k, i.e. greater than 0, then then the asymptotic curve will be in first and third quadrant. Okay. Negative k. So if k is less than 0, then asymptotic curves will be in second and fourth quadrant. For those of you who haven't figured out what a quadrant is, here's a graph. Quad meaning 4. Okay, this is the first one, this is the second one, this is the third one, and this is the fourth one. These are the 4 quadrants. Okay. Again, some examples here: positive 1, positive 1, positive, negative. Okay, so you can see that this, if you draw it out, is going to appear in the this particular quadrant. Okay, if you draw this out, it's going to appear in either this one or this particular quadrant. All right. And again, it all depends on whether x is positive or negative, or whether x is positive or negative or positive. Okay, that's going to determine whether it comes in here, whether it comes on this side, the positive side, or the negative side, or the negative side or the positive side for x. .4 you can sketch curves of functions to show points of intersection and solutions to equations. Okay, on the same diagram, so this is example 8, sketch the curves with the equations y equals x minus 3, and y equals x squared 1 minus x. So again, all they've done here is on the same diagram sketch the curves. They've identified where the points cross the axes, okay, for both of them. So you can see they have 0, 0, 3, 0, 0, 0, or 1, 0. Okay. And then again, they follow the same rule. What happens when between the two x coordinates, to appreciate where y tends to, and then they've just drawn them together to make your life a little bit easier for this one. First, do the first point, okay, then draw it out, then do the second one, and then draw it out, so that you have 2 graphs. You're not doing them simultaneously, which may cause confusion. You may get muddled up with numbers. Do it one at a time at your own pace. Okay, and then in this particular example from the graph, I'm just going back to reread the question. Find the coordinates of the point of intersection. So this is where they intersect. This is where the 2 graphs meet. The coordinates are the same. If that's the case, that means that they have to equate to one another. Okay, so if we say that the numbers, if we're asked show where the points intersect, intersection just means where the coordinates are the same. So that means that for y, they're going to be equal to one another. So intersection, okay, means where do the coordinates meet such that they are identical. One other word to use is equal. And again, this gives us the equality sign. So all they've literally done here in this particular example is they've multiplied out the brackets, which is the first step. Then they have cancelled out the quadratics. And then they've been left with x3, taking it to the other side. Okay, and then they've refactorized, and again they've factorized using the difference of two squares. Remember this rule that we mentioned, that squared minus y squared minus y. Yep, it's come back to haunt us. And then so we have these three particular x's. Then you just reinsert x square root of 3 0 square root of 3 into any one of the equations. Could be this one, or could be y equals any one of them, and you'll get the answers, okay, that correspond to different values of x. So here we have this answer, b is 0 0 and c is such. So when you come to pinpoint which one is which, then you'll have to ascribe each coordinate to the different points. Okay, and so you'll go on to see that that was a very simple example. You have another one here to do on your own, and you can just follow the steps that they give you here. And then finally you just have another group of exercises to do. Okay, and again this is just combining the different things that you've learned before. So we'll stop there, and in our next video we'll discuss subsection 4.5. There was a lot to take in for this particular episode, but we just want to get through things in a quick manner so that we don't delay our progress onto the other steps. So we'll see you for our next video. Thank you very much, and bye bye.